Alright people, we're back on it again. So what are we doing today? Adding and subtracting rational expressions. So we've already done multiplying, dividing, and simplifying. So now let's do adding and subtracting. So what are the steps that we need to do to add and subtract rational expressions? First thing we need to do, find the LCM of both fractions, which is the least common multiple. Rewrite the fraction using the least common multiple. Add and subtract the fractions. Simplify and look for the common factors and simplify if necessary. So in some cases you might be able to simplify. It doesn't work every time, but more likely you should be able to simplify. So what we're going to do now is just go over a couple of examples. So let's start with example 1. So example 1. So my first step that we first said in the previous slide is what's the LCM? So the least common multiple. So in this situation we have both of the denominators are exactly the same. So what that means is the LCM of this situation, LCM, will be x squared plus 5. So they're both the same, so that's what they both can multiply up to be. So I'm going to go ahead and start out with that, x squared plus 5. Now, when I have both the LCM, when I have the denominators the same, all I have to do really is just add the top. So a plus x would be a plus x. And as you see, that's very simple, right? That's our answer. So we're done there. So this is our answer for example 1. Now, let's go to an example where the denominators are not the same. And our first one is going to be example 2. So in example 2, now in this situation we need to find the LCM. The LCM is going to basically be the hardest part of the whole problem. But once you get it down, everything will flow real easily. So let's first look at these two denominators. So that when you find the LCM, you got to think in your head, what do both of these denominators multiply up to? For example, let's start with just the numbers. The 3 and the 12. What can I multiply times 3 and what can I multiply times 12? What's the smallest number they can both multiply up to? Based on just looking at the numbers, we know that the numbers that they both can multiply up to is 12. So go with 12 first. Now looking at the variables, which is x squared and x, what can both of these multiply up to? And you see here, both of these can multiply up to x squared. Does that make sense? So the least common multiple is the smallest number that both this denominator and this denominator can multiply up to. So what's missing on this side to get this LCM right here? If you see, I have to multiply times 4 on this side. Whatever I do at the bottom, I got to also do to the top. So times 4 here. On this side, I got to multiply times x. It's missing an x because I want this 12x to be 12x squared. So times x here, times x here. Now all I got to do is multiply it out. So I get 32 over 4 times 3 is 12x squared minus, I'll multiply times x on the top, will be 5x squared over 12x squared. Now as you see here, my denominators are exactly the same. So now the hard part is over. So now what we're going to do, we're going to subtract. So when I subtract, going back to add, subtract, and polynomials we did before, what we do when we subtract, we change this to a positive and we make this a negative. So now what we have here is 32 minus or plus negative 5x squared over 12x squared. Now where I would be, what I'm going to try to do now is see if I can reduce. Can I divide anything by this number, and this number? And as you see here, nothing can be divided. There's not a common number that can be divided into any of these numbers here. So we know that this is our answer. We are actually done. So this is example 2. Now the key thing I want to focus on, the LCM is actually the hardest part of this whole problem. What can both of these denominators multiply up to be. Okay? Multiply up to. That's the key word. Alright, now let's go to another example. Example 3. Now, so looking at this right here, we have x squared, the denominator is x squared, 2x to the third. So, LCM again. So what can this number, x squared, and 2x to the third multiply up to? Based on what we did a minute ago, you should be able to figure this out pretty quickly. The one that both of these can multiply up to would be actually, on this side I have a 1 here. So what can I multiply, looking at the numbers, what both of these can multiply up to? Let's do it 2, right? And on x squared and x to the 3, what can both of these multiply up to? It would just be x to the third. Now that would be my LCM here. 2x to the third. Now, what can both of these, I'm going to change color for a second. What can I have to multiply times this side to get the LCM of 2x to the third? I need to multiply a 2 and what else? A x. So whatever I do to the bottom, like I got to do to the top. 2x here. And on this side, I'm already basically done. So I don't have to do anything to this. I can multiply times 1 if you have to multiply, just to make sure you know. Or you can just leave it the way it is. So now I'm going to multiply this side over here. So 2x times 2 would be 4x squared. 2x minus 1 would be a minus 2x. And I'm going to put all that over 2x to the third. Right? Because 2x times x squared, add the exponents, we multiply, we get 2x to the third. And now we're going to do plus. And like I said earlier, we're going to leave this the same. 3x over 2x. Now when I multiply 2x to the third, when I add these together, add the top together, what do I get? 4x squared. Now, minus 2x plus 3x is going to give me a positive 1x over 2x to the third. Now, if you see here, is there anything that we can pull out of any of these numbers? Is there like a GCF that we can pull out of here? Yes, there is. We can pull an x out. As you see, there's an x here, there's an x here, and an x here. So in this situation, I can actually simplify. So I get 4x plus 1 over 2x squared. So as you see here, I pulled my x out because there's an x here, there's an x here, and an x here. So as you see, there's something that's in common between all of this whole group of numbers right here, or expressions. So we pull the x out, and this will finally be my answer. 4x plus 1 over 2x squared. Okay? So this is our answer. Now let's look into another example. Example 4. Now this is where we're getting into the trinomials. What's a trinomial again? Trinomial has 3 of them, right? So whenever we have a trinomial, or we always want to just go ahead and just factor it out. Let's go ahead and factor this as far down as we possibly can. So using my x, right, my x box, I don't necessarily have to use the box because this is a 1. So I'm just going to use my x to factor this out. I'm going to multiply. So I'm going to multiply right here. 1 times 4. I'm going to put a multiplication on the top, which should be 4. And I'm going to do a multiplication on the top. And I'm going to do my addition at the bottom. And this will be 5 right here. It goes in the middle. Now what times 4 can add to be 5? And of course, everyone knows 1 and 4. So that can be broken down to, this right here can be broken down to x plus 1 and x plus 4. And right here, minus 5 over x plus 1. Now, my LCM again. Now I have x plus 1 and x plus 1 times x plus 4. So what can both of these multiply up to? This is very simple if you look at it really, you gotta look at it really quickly though. That this right here needs to be multiplied times something to get this. So as you see here, my LCM in this situation, I'll put it right here, it's gonna be x plus 1 and x plus 4. Because I need to multiply times something on this side to get this exact same thing. So let me change color for a second. So what that means is I need to multiply this side right here times x plus 4 and also multiply the top by x plus 4. Now this side is already done, so I leave it the same. So what I get now is 1 over x plus 1 and x plus 4 minus, and I'm going to go ahead and just go ahead and simplify this. 5 times x would be 5x plus 20 over x plus 1 times x plus 4. Now what I like to do is go ahead, I have a minus sign here. What I like to always do when I have a minus sign, let's go ahead and switch it around. So plus, make this a negative, and also make this a negative, right? We never want to subtract, we always want to just change our signs, right? So my answer would be, I'm going to bring it up here. My answer now would be, I'm going to keep the bottom the same. So that would be x plus 1 and x plus 4 over, let's go ahead and bring everything together, negative 5x, I'm going to put it in standard form, negative 5x plus a negative 20 plus 1, which actually gives me a negative 19. Now, is there anything that can be factored out of this whole expression right here? As you see, no, nothing can be factored out. So we're going to leave this the same. This is our answer right here. Alright? So, I think we have one more example left. And we do. We have one more example left, which would be example 5. Actually, I think we have 2 more examples left. So, in this situation right here, what do we need to do again? We have a trinomial. What are we going to do? We're going to break down the trinomial. So, we're going to break down the trinomial, and we get this trinomial right here would be, I'm going to use my X box again. And I'm going to put, this is a 1, I'm going to have to use a box because I only have, only to the first, it's only 1. So that'll be 18 on the top. And what's in the middle goes to the bottom, that's plus. So multiply on the top and add to the bottom. So what numbers will add to be a negative 18? Add to be, will multiply to be negative 18 and add to be a positive 3. And as you see, you'll get a 6 and a negative 3. And if we factor that out, we get x minus 5 over x plus 6 and x minus 3. And we plus 2x over x plus 6. Now this follows the same pattern that we learned in the previous example. What I need to multiply by, the LCM of this right here would just be, what can both of these multiply up to? X plus 6 and x minus 3, which would be x plus 6 and x minus 3. So what I need to multiply by, I'm going to multiply by this side only because this side already has the LCM that I need. So that would be x minus 3 and x minus 3. So what we end up with is x minus 5 over x plus 6 and x minus 3 plus 2x squared. I'm going to go ahead and multiply this in. And 2x squared minus 3, which gives me a minus 6x over the x plus 6 and the x minus 3. Now that we got that done, we're going to keep the bottom the same. And we're just going to basically add like terms here. So we got the square goes first, so 2x squared. The minus 6x plus the x gives me a minus 5x. And then the minus 5. Alright? So as we see here, we got everything in order. We might go ahead and take one more step to factor this, but I think this really won't be able to factor. So we're going to leave that just like this for now. And we'll factor it down a little further later. So we got, this will be our answer here. Now, last example. Example 6. Now this is the one example that I really was waiting for. As you see here, we have x minus 3 and x plus 4. Now what's my LCM on this one? So this one is kind of tricky, right? What can this one multiply up to and this one multiply up to be the same? Now this is actually pretty simple. If you can't find an LCM of both of them, you just multiply them both together. So my LCM for this one would just be x minus 3, excuse me, and x plus 4. We just multiply them all together. So what I need to multiply on this side, I need to multiply on this side x plus 4, and what I need to multiply on this side, x plus 3. And whatever I do to the bottom, I gotta do also to the top. So as you see here, x plus 4, and now we got x plus 4, right, times x plus 6 over x plus 4 and x minus 3, right, minus x minus 1 times x plus 3 over x plus 4 and x plus 3. Now the hard part, we need to go ahead and just multiply this out, and I'm going to go ahead and show you how to do this one. You could actually do the box on this, or yeah, let's go ahead and just do the box, which will be an x here and a 4 here and an x here and a 6 here, which would be x squared plus 6x plus 4x plus 24, and like terms would be x squared plus 10x plus 24, and so that would be our top, which would be x squared plus 10x plus 24 over the bottom, which is x plus 4 and x plus minus 3, and minus, let's go ahead and do the box on this one, and I'm going to put that on this side, which would be x minus 1 and x plus 3, which would be x squared, that's 3 right there, x squared plus 3x minus 1x minus 3, which gives me x squared plus 2x minus 3. And as you see here, this is a minus. So we're going to go ahead and change everything to minus. So this should be a positive. Make this negative, and make this, change this negative to a positive. So that would be x squared, negative x squared, plus, well, minus 2x, because it's a minus here, plus 3, over everything we have, which is x plus 4 and x minus 3. And now we're going to do what? What are we going to do now? Now everything's done, let's go ahead and cancel out things that we can add, that we can cancel out. So the x squared and this x squared cancels out. Now this 2x right here, we'll go with this one right here, so add like terms, so we get 8x. This 3 and this 27 go together, so we get a positive 27 over x plus 4 and x minus 3. Now that is your answer. That's a combination of everything we've learned for the last couple of weeks. What I would advise you to do is go back, rewind all these examples, try to do each one, and make sure that you fully understand what's going on. Our key thing that you need to focus on is finding your LCM. If you understand how to find your LCM, the whole process is very simple. And that should be it, guys. Hope this helps. If you have any questions, ask Ms. Black, Ms. Glover, or you can always ask me. Alright, there you go, Langston Hughes. Hope this helps.